Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Longest square streak in an array, Leetcode 2501. In this problem, we are given an integer array nums and we should return the length of the longest square streak in nums or return -1 if there is no square streak. A subsequence of nums is called a square streak if the length of the subsequence is at least 2 and after sorting the subsequence, each element except the first element is the square of the previous number. A subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Then in example 1, for the given nums array, output is 3 because we can choose the sequence 4, 16 and 2 and after sorting it, the sequence becomes 2, 4 and 16. And this is a square streak because length of the subsequence is greater than 2 and 4 is square of 2 and 16 is square of 4. So we can actually form a square streak. And because this is the longest square streak, we will return 3 as our answer. Now in example 2, for the given array there is no square streak, so we will return -1 as our answer. Now in terms of solution, one of the naive approach can be to generate all possible subsequence of the given array nums like 4, 3, 4, 6, 4, 16 and so on, and then 4, 3, 6, 4, 3, 16 and so on, and check each subsequence to see if it meets the criteria of a square streak, and longest of such sequence will be our answer. In example 1, only 2, 4, 16 is that subsequence. But generating all the subsequences will require time complexity of 2 to the power of n, and then checking if subsequence is meeting the criteria of a square streak require time complexity of O of n, and hence overall time complexity will be O of n into 2 to the power of n, which is super inefficient. A more efficient approach is to sort an array because then we get the smallest number first and we can start building the streak starting from it. For example, when we sort the given array in example 1, we get the sorted array as 2, 3, 4, 6, 8, 16. And now we can start iterating on the sorted array with the smallest number first. For example, we start with number 2 and see if the next number in the square streak, that is 2 into 2 equal to 4, exists in the array. Similarly, if we see the number 3, the next number for it will be 3 into 3, that is 9. So we try to find 9 in the array. And for finding the next number in the square streak, we can use a binary search because the array is sorted, but that will require time complexity of O of log n, where n is the number of elements in the array. So better approach is to build a hash set on the array because then the time complexity reduces to O of 1. So now our hash set will contain the elements 2, 3, 4, 6, 8 and 16. And now we can start iterating on this sorted array to form the streak. First we see element 2 and try to find the squared streak starting from number 2. So we remove it from the set. So our square streak length becomes 1. Then the next number in the streak will be 2 into 2, that is 4. And we see that it exists in the set. So we remove 4 from the set and increase our streak length to 2. Now 4 squared is 16 and we can see that 16 also exists in the set. So we remove it from the set and increase the streak length to 3. Then 16 squared is 256, which is not in the set. So our sequence ends here and the length of the sequence will be 3, which is also the maximum we have seen so far. Then we start with number 3 and we can see that 3 exists in the set. So we will remove it and mark the length of the current streak as 1. Then we see if 3 squared exists in the set and the answer is no. So the sequence ends here. Then we go to number 4 and we see that it does not exist in the set because we already used it in another sequence. Then we go to number 6. It exists in the set. So again our current streak length will be 1 and we remove 6 from the set. But 6 squared 36 does not exist in the set. So our streak ends here. Then we go to 8. We can see that 8 also exists in the set. So we remove it from the set and again our current streak length becomes 1. But 8 squared, that is 64, does not exist in the set. So our streak again ends. We come to 16 and we can see that 16 does not exist in the set. And now we are done with the nums array. And for us the longest streak length was 3 and that was our answer. And now let's jump into the code part. First, let's sort this array in the ascending order so that smaller elements come at the start. Now let's create set from the array for O1 lookup times and to handle the duplicates. For that, we can just loop on the array and add all the numbers to the set. Let's also define the variable answer to track the maximum streak length found so far. Now we can iterate on the sorted array. Let's initialize the current streak length to 0. Let's also define the current number of the sequence. Initially, it will be equal to number itself, but later on we will square these numbers. So to avoid overflow, let's take it as long. Now, while the squared number exists in the set, we will continue to increase the length of the current streak, remove the current number from the set, and get the next number in the sequence by squaring the number. But if this current number is more than integer.max value, that means that will result in the overflow. So we can break out of the loop, because in the problem description it was given that nums is an integer array. So any number out of this integer range will not be part of the sequence. And finally, we will check if length of the current streak is more than 2 and is also the maximum length. Then we will set max length equal to current length. And finally, we will return our answer. And if throughout the loop answer was never set, then it will return the initial value -1. Now let's submit this code. Awesome. In terms of time complexity, it will be O of n log n, where n is the number of elements in a nums array, mainly coming from sorting the nums array. And then when we are adding the elements to the set, that takes O of n time. And finally, when we go through the sorted nums array, it again roughly takes O of n time, even though it looks like a nested loop, because at each step we are doubling the number. And let's take the smallest number, say 2 in the sequence. Then it can be doubled 32 times, because the integer length is 2 to the power of 32. So at maximum, the inner loop can run only 32 times. So that's why the overall time complexity is O of n log n. And in terms of space complexity, it will be O of n, because we are storing the nums array in the set. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.